Hello and welcome. My name is Derek Remish and today I'm going to give a short video tutorial about musical sequences. This presentation has 6 parts. The first section is about how to identify sequences. A sequence is the repetition of a musical idea at a different pitch level. The initial statement of the musical idea is called the model, and each repetition is called a copy. Sequences may ascend or descend. A sequence label indicates the vertical distance between the model and each subsequent copy. This distance is indicated by an interval. Sequence labels include direction, that is up or down, and generic interval, that is second, third, fourth, etc. Generic just means that you do not need to indicate the quality of the interval, such as major, minor, or perfect. So for example, a copy might repeat the model up a third or down a second. The interval of repetition is rarely larger than a fourth. Sequences may also be diatonic or chromatic. Diatonic means in the key, with no additional accidentals. In contrast, chromatic means outside the key, with additional accidentals outside the key signature. This chapter will focus only on diatonic sequences. Next, we'll look at melodic sequences. In a melodic sequence, a single line melody is repeated. Here's the opening of the prelude from Wagner's opera Die Meistersinger. Only the outer voices are given. Let's listen. We see that in measure 8, the soprano line or highest voice is repeated. We label the first occurrence as the model and each repetition as a copy. This is a melodic sequence because only one line, the soprano, is sequential. The bass is not. Therefore, melodic sequences are possible even if there are other non-sequential voices present as well. When identifying sequences, always measure from the first note of the model to the first note of the copy. If we apply this to Wagner, we see the pattern is E, D, and C. In other words, this sequence descends by step. We abbreviate this as D2. Here's another example from Sammartini's Symphony in C major. Let's listen. Here, the model is 2 bars long, and it's repeated 3 times. The first note of the model is E, then D, C, and B. So just like the Wagner, each copy descends by steps, so we call this a D2 sequence. Note that the model may be any length, but it is usually between a half bar and 2 bars long. Next, we'll discuss harmonic sequences. In a harmonic sequence, all of the parts, soprano, bass, and inner voices repeat. Harmonic sequences are labeled the same way as melodic sequences, by direction and generic interval. Here's the opening bar, or opening bars, from the theme of Handel's C major chaconne. The recording plays the whole theme. Here the model is 2 bars long and there's one copy. We see that the model begins with an E and the copy begins with an F. So this sequence ascends by second. It's an A2 sequence. Note that we could just as easily have measured from the bass, that is C to D. This would yield the same answer, or A2. As long as you measure from the beginning of the model to the beginning of the copy, it doesn't matter which voice you use. Harmonic sequences often include a harmonic analysis, also called Roman numeral analysis. Here the key is C major and the chords are 1, 4, or 1, 5, 2, and 6. The chords in a harmonic sequence may be triads or seventh chords, and they may also be in root position or in inversion. The next section discusses linear intervallic patterns. In a harmonic sequence, the model always has 2 chords. A linear intervallic pattern, abbreviated LIP, identifies the interval between the first notes in the outer voices of each chord in the model. Therefore, an LIP always has 2 numbers. This pattern of intervals is then repeated in each copy. Note that LIPs are only possible in harmonic sequences. So let's find the LIP for the opening of Handel's chaconne. We start by measuring the first notes in the outer voices of the model. They are E and C, together making the interval of a tenth. By convention, thirds in LIPs are identified by their compound interval of tenths. Next, we look at the second harmony in the model, which is D to G, or a fifth. Therefore, this sequence has an LIP of 10-5, and we can check whether this LIP is applied consistently in the copy, and we see that, of course, it is. The Sammartini example actually includes a bass line. Let's listen again. The bass and soprano together make an LIP of 10-8. This pattern is then repeated in each copy. As with any harmonic sequence, we can add a Roman numeral analysis. This sequence happens to include seventh chords on every other harmony. We will discuss one more type of harmonic sequence that has an additional name, the circle of fifths sequence. It's extremely common. This label differs because it describes the root motion of each chord. It's called the circle of fifths because the root of each chord in the sequence is a fifth lower than the last one. Each copy always descends by step, so the circle of fifths is a type of D2 sequence. Here's an example. Let's listen. This This particular example of a circle of fifths sequence has an LIP of 10-8, as you can see. A Roman numeral analysis is included, and I've even labeled the chord roots. You can see that each one falls by fifth, from C to F to B, etc. Circle of fifths sequences are harder to spot when the chords are in inversion, as shown here. Let's listen. This is the same sequence as the previous example, but now there are inversions on every other chord. This creates a different LIP of 10-6. The important point is that the chord roots still descend by fifth, even though the bass does not. Remember that the root is the lowest note when the chord is stacked in thirds, but the bass is the lowest note at any given point. Regardless of inversions, the circle of fifths sequence will always descend by second between each model and copy. Notice here that the model is a half bar long and the harmonies change every quarter note. The rate of harmonic change is called the harmonic rhythm. So the harmonic rhythm here is a quarter note, one harmony per quarter note. In fact, the Sammartini example also follows the circle of fifths. The Roman numeral analysis is the same as the previous example, only now with seventh chords. Listen again and compare. The Sammartini has a slower harmonic rhythm than the previous example. The model here is 2 measures long rather than a half bar, and the harmonies change every measure. So the harmonic rhythm here is 1 chord per measure. Let's do a quick review of the main points presented in this video. A sequence is the repetition of a musical idea at a different pitch level. The initial statement is called the model, and each repetition is called a copy. A sequence label indicates the distance between the first note in the model and the first note of the copy, indicated by direction and generic interval. Sequences may be diatonic or chromatic. In a melodic sequence, a single line melody is repeated. In a harmonic sequence, all of the parts, soprano, bass, and inner voices, repeat. In a harmonic sequence, the model always has 2 chords. Harmonic sequences often include a Roman numeral analysis. A linear intervallic pattern, or LIP, identifies the interval between the first notes in the outer voices in each chord in the model. LIPs are only possible in harmonic sequences. The circle of fifths sequence differs from an LIP in that the name identifies the root motion between each chord. Each root falls by fifth regardless of chord inversion. Each copy in the circle of fifths sequence is always down a step. And lastly, harmonic rhythm is the rate at which harmonies change. I thank you very much for your attention, and feel free to get in touch with me.